In this question, we're given an irregular hexagon, ABCDEF. We're told that the shapes ABEF and CBED are congruent parallelograms, where AB equals BC equals x centimeters. We're told that P is the point on AF and Q is the point on CD, such that BP equals BQ equals 10 centimeters. And now, given that angle ABC is equal to 30 degrees, we need to prove that cos PBQ equals 1 minus 2 minus root 3 over 200 x squared. So let's start by defining some key terms. If two shapes are congruent, that means they are identical in size and shape. And now we're also given that we need to prove that cos PBQ equals 1 minus 2 minus root 3 over 200 x squared, and the x squared suggests that our answer will be in terms of x. So where we're told that AB equals BC equals x centimeters, we don't really need to find out what x is, because our answer is in terms of x. And now we can start to layer up our diagram. AB equals BC equals x centimeters, and BP equals BQ equals 10 centimeters. Now another thing that we can note down is that the line AC is equal to the line PQ, and that's going to help us at a later stage. So now we can start by drawing separate triangles, which will help us to work out what we need to find out. We'll start by drawing triangle ABC. We know that angle ABC is 30 degrees, and that AB and BC are equal to x centimeters. Now we can draw triangle PBQ. We know that BP and BQ are 10 centimeters. And now if we look at the base of triangle ABC and triangle BPQ, well, we said that AC and PQ are equal, so we can call this side A. And now since we need to prove that cos PBQ is equal to 1 minus 2 minus root 3 over 200 x squared, this suggests that we'll need to use cosine rule. And cosine rule is given by a squared equals b squared plus c squared minus 2bc cos A. So now let's take a look at finding A. Well, we don't have enough information in triangle BPQ, but we do have enough information in triangle ABC. So now let's apply cosine rule to triangle ABC. We'll say that A is equal to the labelled A on our diagram. We can say that B equals x, C equals x, and then capital A is equal to 30 degrees. So now let's plug this in to cosine rule. A squared equals, well, B squared plus C squared is x squared plus x squared minus 2 times x times cos 30. And now we know from our trigonometric identities that cos 30 equals root 3 over 2. So now let's simplify this. We say that a squared equals 2x squared minus 2x squared multiplied by root 3 over 2. We can now multiply 2x squared by root 3 over 2. So a squared equals 2x squared minus 2x squared root 3 over 2. And now we can simplify this even further. We can divide both the numerator and the denominator by 2 for 2x squared root 3 over 2, and we're left with a squared equals 2x squared minus x squared root 3. And now there's one final step to simplifying this, and we can factorize x squared out of the expression. So we're left with a squared equals x squared brackets 2 minus root 3. And now we don't need to find out what a is. We can actually leave this as a squared, because when we apply cosine rule to triangle PBQ, we're going to need to have to use a squared anyway. So it's just easier to leave this as a squared rather than square rooting the entire expression. Since we've now found what a squared is, and we said that PQ is equal to AC is equal to A, we can apply cosine rule again to find cos PBQ. So we said that cosine rule is a squared equals b squared plus c squared minus 2bc cos A. So now for triangle PBQ, we can say that A is equal to A, B is equal to 10, C is equal to 10, and capital A is equal to angle PBQ. But we don't know what this angle is, and that's what we're trying to find in terms of cos PBQ. So now let's start by substituting in the values. We have A squared equals 10 squared plus 10 squared minus 2 times 10 times 10 times cos PBQ. But we said that A squared is equal to x squared brackets 2 minus root 3. So we can say that x squared 2 minus root 3, and let's simplify this. 10 squared plus 10 squared equals 100 plus 100, which is equal to 200. Take away 2 times 10 times 10 times cos PBQ. Simplifying this, we can say that 2 multiplied by 10 is 200, and then cos PBQ stays as cos PBQ. We want to make cos PBQ the subject of this expression, so what we can do is move minus 200 cos PBQ to the other side. And then we're left with 200 cos PBQ plus x squared 2 minus root 3 equals 200. And then now we can bring the x squared 2 minus root 3 over to this side. And so we'll be left with 200 cos PBQ equals 200 minus x squared 2 minus root 3. So in order to be left with cos PBQ, we need to divide both sides by 200. So we'll have cos PBQ equals 200 minus x squared 2 minus root 3, all divided by 200. But we can split this fraction up. We can say cos PBQ equals 200 over 200 minus x squared 2 minus root 3 over 200. Now we can simplify this further. We can say that 200 and 200 cancel out, and so we're left with 1. So we can say that cos PBQ is equal to 1 minus x squared 2 minus root 3 over 200. And we can leave the x squared at the end and write this as cos PBQ equals 1 minus 2 minus root 3 over 200 multiplied by x squared. And that's how you get the final answer for this question. This question is worth 5 marks, so let's take a look at where these marks are allocated. The first mark will be for stating that cos 30 equals root 3 over 2, which we've done very clearly. Now the second mark will be for finding a squared, and for leaving this as a squared rather than square rooting it to find a. And so we found that a squared equals x squared brackets 2 minus root 3, and we've clearly shown our working out, and that will get us that second mark. Now the third mark is for using cosine rule to find an expression for cos PBQ. And we used it over here. We said a squared equals 10 squared plus 10 squared minus 2 times 10 times 10 times cos PBQ. And that will get us that third mark. The fourth mark will be for using what we found for a squared earlier, where we said a squared equals x squared 2 minus root 3, and for substituting this in to our expression for cos PBQ. And we said x squared 2 minus root 3 equals 200 minus 200 cos PBQ, and that's our fourth mark. And our fifth and final mark will be for getting the conclusive statement that cos PBQ equals 1 minus 2 minus root 3 over 200 x squared, which is exactly what the question asked us to prove.